Assalamualaikum warahmatullahi wabarakatuh. Well, in this video, we are going to look at the example of finding the covariance of x and y, and basically this is about applying the idea of product moments, and this video is specifically for the discrete case. Okay, so what we have right here is a table that contains the joint probability mass function. So we have values of x right here. We have from 0, 1 and 2, and these ones right here are the values associated with random variable y. Okay, and in order to find the covariance of x and y, this is the formula that you have to use, which is finding the expected value of xy minus ex times ey. Okay, and we're going to start off with finding this one right here. Okay, expected value of xy. Now, according to the formula, so this is what we're going to start first, and the formula here is given by this one. Expected value of xy is going to be involving the double summation, and this is what we're going to find. So we're going to just plug in that item right next to our fxy. So fxy is this one, the joint probability mass function, and this one here corresponds to the values of y, and this one corresponds to the value of x. And we know that y begins from 0, so this is the beginning point. Y is equal to 0, and we're going to consider changing the values of y until y is equal to 2. And similarly for x begins from 0, and we will keep on changing later on, substituting the values of x until x is equal to 2. Okay, so that one is the ending point. Okay, so that's what we're going to do. We're going to start substituting the values of x and y accordingly. So we're going to start with x equals to 0 and y equals to 0. We're going to plug in those values inside this x and y, okay? Right, so following this formula right here, we have 0 times 0, f0, 0. Okay, so we start off with x equals to 0, y equals to 0, and then we're going to change the value of y. So we're going to keep on changing the inner part of this. Okay, so we are going to maintain x equals to 0, but keep on changing the values of y. So we have 0 times 1, and then f0, 1, and then we have 0 with 2, y is equal to 2, f0 and 2. Okay, now after we're done with that, the values of y have already been changed from 0 until 2. Then we're going to change the value of x. So x is 1 with y 0, and then maintain the value of x at 1, and then keep on changing the inner values here, the values of y. So we have 1 times with 1, so this is what we have, and then we have 1 times with 2. Okay, then we are done. Okay, because we have done changing the values of y from 0 until 2. There is no more substitution that we can do with regards to y. So now we're going to move back to the outer circle, which is the values of x has to be changed from 1 to the next one, which is 2. Okay, I forgot this sign. Okay, so now we have 2 times 0, f2 0, plus 2 times 1, f2 and 1, and then 2 and 2, f2 and 2. Okay, so that's what we have. Now you can see that for anything related to 0, we can cancel out because this one becomes 0. This term right here becomes 0. 0 times 0, 0. Multiply with whatever is also going to be 0. This one also can be cancelled out because we have this 0 right here. This one also can be, result to 0 immediately, we know that. This one also results to 0, and this one also will result to 0. Okay, now we are left with just 4 more terms to consider, which is this one, 1, 2, 3, and 4. So that's what we're going to do next. We're going to focus on that. So here 1 times 1 is 1. Multiply with the joint probability. So we have x equals to 1 and y equals to 1. We are talking about this part here, x1, y1. So multiply with 1 over 6 plus 1 times 2 is 2. f1 and 2, so x1, y2, this is the result, 0. Next, 2 times 1 is 2, f2, 1, we're talking about this value, which is 0. And finally, 2 and 2 is 4, f2 and 2 is also 0. And final answer to this one is going to be 1 over 6 for the value of exy. Okay, so exy here is going to be 1 over 6. Right, next we are going to find the value of ex. Is ex, okay? So in order to find this value of ex, we know that the formula for finding ex has to involve finding the marginal distribution, okay? Because in order to find ex, this is the formula, which is the summation of x times fx. Okay, this is with regards to the value of x, and we know from the table right here, x can take values of 0, 1, and 2, and we can start preparing the marginal distribution of x. Okay, so we need this marginal distribution of x, just x alone. So we know that the values of x can be from 0, 1, and 2, and we need to find what is fx. So when x is 0, okay, from the table right here, when x is 0, I'm just going to erase this part, okay. So when x is 0, we know that the values of fx is going to be 1 over 6 plus 2 over 9 plus 1 over 36. And that one is equal to, if you punch in the values into your calculator, you will get 5 over 12, yeah? Okay, okay, again, we have 1 over 6 plus 2 over 9 plus 1 over 36. Okay, so 5 over 12, that one. And then when x is equal to 1, this is what you need to add up, 1 over 3 plus 1 over 6, and that one is equal to 1 over 2. Finally, for x equals to 2, the probabilities associated with that is going to be 1 over 12. And if you want to make sure that you're doing everything all right, you have to make sure that all these probabilities are greater than or equal to 0. And if you add them up, the result should be equal to 1. Okay, right. So now we're done with finding the marginal distribution of x. So we're just going to apply the formula and solve this part right here in finding the expected value of x. So x begins from 0 until 2, and basically what it means is we are going to have 0 times f0 plus 1 times f1 plus 2 times f2. Okay, so this one, the result is 0, we don't need to do anything. 1 times f1 is 1 over 2 plus 2 times f2 is this one, 1 over 12, and the result here is going to be 1 over 2 plus 1 over 6, and this one is equal to 2 over 3. Okay. Okay, now we're going to move on to finding. So this one is 2 over 3. So we're going to move on to finding this one, this right here. What is the expected value of y? And we're going to follow the same idea, which is to find the marginal distribution of y. Okay, and the formula to find the expected value of y is from y equals to 0 until 2, y dot y. Okay, and here is the marginal distribution of y. We know that y can take values of 0, 1 and 2 based on the table given here, and y, when y is 0, the marginal, the probability associated with that fy is going to be 1 over 6 plus 1 over 3 plus 1 over 12. Okay, and that is equal to hang on. So that is equal to 7 over 12. So here is 7 over 12. This is fy. Right, and then when y is equal to 1, you need to add up these probabilities. So that is 2 over 9 plus 1 over 6, and that is 7 over 18. So this is 7 over 18. And finally, when y is equal to 2, you need to add up this part, and it is equal to 1 over 36. Okay, so we're just going to apply this formula right here. So we begin with when y is 0, it has to be multiplied with f0. When y is 1, that is f1 plus 2 f2, and we know this results equal to 1 and to 0. So 1 times f1 is 7 over 18 plus 2 times f2, which is 1 over 36, and the result that we get here is going to be okay, it's going to be 4 over 9. 4 over 9. So this is that part here for this one. This is 4 over 9, and we will just use these values applied into this formula, and you will be able to find the covariance of xy. Therefore, covariance of xy is equal to 1 over 6 minus 2 over 3 times with 4 over 9, and the result that you get here is going to be equal to, hang on, negative 7 over 54. Okay, so that's the answer for this example right here. Thank you very much for watching, and I will continue with another example related to continuous case in the next video.